Good morning, everybody. Thank you for joining us today. It's 11 o'clock here in Cleveland, Ohio, and you'll see that we are not in the TCP studio this morning. We are actually sitting on a truck full of products, because today we're talking about how your order becomes a product, the lighting manufacturing process. So Ellis, what do you have to say?
I thought the team decided they're going to ship me together with the products today. So I'm sitting in my truck right now, sitting on, oh, by the way, no double stacking. Sorry, hey, shh. Okay.
You guys can take them, it's fine.
Okay, and then, look, this is what we call TCP standard. I'm literally in the truck right now. Okay, they're going to fill up this truck slowly. If you look at this blue standard, it's the highest TCP service standard with the best packaging, and obviously you can see how tough it is. And while walking from outside, so today called reverse everything. Cartoon, something like that. What's the name of the cartoon?
What do you know the name of the car? The actual name? I remember it was like How a Bill Becomes a Law, and it was amazing. And I can remember the bill. Oh, it was amazing. Schoolhouse Rock. Schoolhouse Rock.
Okay, here we go. So today we actually, this is the ending.
This is the ending.
This is the ending. Obviously, the real ending is you help us to install the products into the ceiling, into the office space. But this, as far as we're concerned, our operating people, that's what we do. So
they said the service is bad inside the truck.
Right.
We got to get these Wi-Fi enabled.
So fortunately, they decided not to ship me today.
No,
so
I guess you can stay.
I'm able to walk around with this truck and walk to look at the other products. This is just awesome. We actually stopped the loading right now, so they're not going to hit me. Okay.
Just in that truck.
Right. So that being said, turn around, look at all the blues. Look at all the blues here, guys. Okay.
Don't walk in front of Missy.
You see how it's been loaded up? The blue standard, isn't that great? You can see all the blue here. Okay. All the way to look at all the blues over there.
Those are all ready to roll.
Ready to roll. Okay.
We have one where they're
improve our standard as we speak right now. Okay.
So before they get, those are all ready to go out the door, and here they are getting wrapped up. So this is the next process that they do. And what TCP's done is we've taken a lot of steps to improve what we're doing, so to make sure that your product arrives alive, as I like to call it. So here you have Pedro wrapping it up.
Okay,
don't put your hand in there, Ellis.
Adjust the tightness. Okay.
Yeah, we actually just had all our machines recalibrated to make sure that they're packing at the right level. He's adding the corner boards in. Do not stack sheets. Everything's going down. This is really great.
Right. Exactly. This is how we see here. This is the TCP new standard. We're very excited about this. We want to make sure all the TCP products arrive at your location in a perfect shape. Perfect shape.
It's amazing.
That's a part of our service. So that being said, let's just keep moving.
Let's keep going. Paul, what's next?
Right, so everybody knows Paul. Okay. Thank you, Pedro. Thank you. So now, let's move into the post area, which you guys know before.
This is our U.S. assemble area. Yeah. But you know, Ellis, those are all our LTL shipments. I just want to point out this crazy conveyor that we have for all of our FedEx ground shipments. So if you're want one or two light bulbs coming to your doorstep, they're probably going to go this way.
Exactly. That's the regular FedEx stuff instead of LTL. And as you can see here, maybe one place they're unloading a container right there.
Oh, they're unloading it. Okay. We can go the other side and show them unloading the container. That's the product to be built that came in from China.
Okay, let's see. So right here.
So these are all the unloads.
Now we're talking about unloads. Okay, unloads are a little bit different from China side.
Ah.
Unloading. We all pack the stuff inside of here. Okay, there are all the light engines for the high base. Am I right? So those kids are working very hard. Okay.
They're not kids, they're young gentlemen.
Right, and they just remember they only went through half of the container.
Yep.
Usually it takes them a few hours to unload the entire container.
Not these guys.
Absolutely. These guys are fast.
Right, okay. When they unload a container, we light up to here. Then those things will go to pause
Area
assembling line
to be
now.
built
Am I right, Paul?
Yeah, well, we put it away and then we picked it. But yeah, okay.
as we need it.
No idea.
So here we are on our way. Woo.
So that's what we do now.
This is all the stuff coming off the containers.
Okay.
Right here.
So you have, let's say, light engine on the one side, and then you have a drivers on the other side.
We got some lamps coming
Okay,
in.
look at what we have here. That's the GPS right here.
4-foot GPs.
Right? Here's all the GPS here.
Yep.
Okay. This is all the trapper.
Ooh, volumetric.
30%
30% of the market.
30% of market is here.
More volumetric.
More volumetric.
Must have got a big order on volumetrics.
Right. Probably enough on that one.
Ooh, there's the drivers.
Oh, the commercial cans.
No, those are drivers.
Oh, the drivers.
Those are
Oh,
drivers.
commercial cans.
Oh, close
No,
enough.
those are the DRV.
Oh, they're the PRVs?
Yeah.
They look like the
Okay.
same size.
So now come to the post area. So Paul, will you walk through? Okay. Walk to
Christian's
the
gonna
side.
hit us.
We don't want to be hit.
Christian won't run you.
I know.
So these are all the products. This is our staging area after it comes off the line. So after it comes off the line, like we produce the product, we put corner boards on it, edge protectors like that all the way down here. And that's just to get it from the here to the DC area. Once it goes to the DC, they rewrap it as the blue standard to make sure everything is correct on that pallet.
That's beautiful. So before they get to this step, they have to actually put it together, right, Paul? So let's see that.
So for instance, down here,
Ellis is just picking through your products
it's okay. Down here we have our flat panel line. We're only running one line today
for panels.
for panels. So you see the panels coming down the line. These are the edge-lit products, not
So
the
they're
backlit.
building some edge-lit.
So you see it comes down the line.
Yeah.
This gentleman will put it in the box. He'll box it all out. We can walk up this line and show
Sure.
you exactly what's going on. So here's our packaging. Over here, we're putting all the labeling that's necessary on the product. So this is the labeling area where they attach the driver on. See the driver over there. So here, this is the product coming in off the container. We're taking the components out. We're putting it on the line. And it's going down, and then they're adding the accessories and drivers or whatever is needed and required.
And we're building edge-lit.
These are edge-lit today.
Those are edges, right?
So as we're walking around,
And over here, they're building some volumetrics.
here we have some volumetric choppers being built. This is a smaller order, so we didn't run it on the production line over here. This is a smaller line. So we're adding the driver on. This is the light engine that we just saw over in the receiving area. Pulled it off, added the light engine.
Making the connections.
Make the connections. We light everything up. Everything is tested and done beforehand. Then it goes into the box and out the door.
Okay.
Cut over to this line here.
We're cutting through.
Oh, there it is. Where's Alice?
Oh, we
Here's what
lost
he was
him.
looking for.
I don't know where he went.
Bob loves when I unpack his stuff he already packed. There he is. Commercial cans. There they are.
Heading out the door.
Heading out the door. I gotta put it back together for Bob here.
Yeah, don't screw it up, Paul.
Yeah, I don't want a customer to get it without all the
All the stuff.
stuff on it. There we go.
And over there, there's some 8-foot vapor tights.
8-foot vapor tank. This is a hot order for us today. Somebody needed these to get out the door, so we hurried up and pulled this order in. So you see this is the light engine here. All the vapor tights come with the hardware and components, okay, for installation. We're adding our driver, doing our wiring. Everything is lit up and tested again once it's complete. And then we move on.
What else are we building, Paul?
Let's go on to here. We have another line over here. Different order. but
More
these are
volume-
More volumetrics. Different
Wow.
order for volumetrics.
Volumetrics are hot today.
Here's
Ooh,
some
and here they're
stuff.
doing some specialty
These
DTEs.
are custom DTs.
Why are these special, Paul?
I'll show you one second here. So this is custom because
black frame and prismatic.
there we go.
Woo! It's like finding a unicorn.
It is. It was kind of like that. Thank you. So we have those running, and those are sample orders. You see over here, we're building battery backup units. These are DTs with battery backup. And a lot of the smaller stuff where we don't have large volumes, you know, thousands, we build on the smaller lines like this.
That's
Because,
awesome.
you know, single seller.
And then before that, it goes over here, which is you'll notice that there's a lot of stuff being staged over here.
Yeah,
that's all the stuff that's to be built for the day.
All this is our incoming product to be built. What we do is, from an operation standard, when you place an order, that order comes in, it creates what we call a work order for that particular product if it's not already in stock. We go in order at order entry. So it got ordered today. Within 3 to 5 days, we build that stuff for you.
Okay.
Assuming we have all the components and product and all that stuff.
But Paul, what happens before it gets here to the guys unloading it on the container? Off the container.
Oh, off the container?
Yeah.
So if we want to back up, if we want to reverse to the container area, we're going to have to go back and look at what happens in our China factory.
Okay,
We
let's
have
do
7
that.
facilities in China.
7?
Yes. We'll walk back through here. Now we're heading back to the studio because we want to show you what happens in China.
Ooh.
How does it get from China to
How does
us
it
to
get
assemble?
from China to us? So we're getting on the plane. We're taking that 18-hour flight right now.
All of our product, most of it comes in on a boat, but
Okay.
you can do a plane if you want.
Well,
And
we're
don't
taking
worry
the
about
plane.
it.
And then, oh, wait, there's Ellis. Ellis, we're in China now.
I know, exactly.
Ni hao.
Ni hao. We're in China right now, okay? So when we
Okay.
talk about it in China, let me just give you a quick flavor of what we do. Now, look at this is how the arriving over here. So let me just quickly walk you through what a China manufacturer is doing. Okay, start with that. As you know, in the entire China, we have 7 locations. Okay, we have 7 locations. They are not together. They are kind of spread out in 7 physical separate locations. Each location is about a 2 hours driving distance. So in other words, right? So in other words, like 100, 120 miles away from each other.
Yeah, I think
Okay.
the furthest, like when you get off the plane in Shanghai, Pudong, it's 4 hours in the car to get to the furthest location.
Right. It used to be, let me tell you the history for the last 20 years. It used to be the big location from China over there. We used to drive 5 hours in a small road.
Oh, wow.
Okay. Old days also has a U.S. team battery over there at that time. I tell you, it's very tough to stay in the car for 5 hours not going to the bathroom.
Yes, it is.
So I always advise people say don't drink when you go on that. That was 5 hours, okay? And then the 5 hours they do build highways. Then the 5 hours between
High-speed train.
no, before that was the 2.5 hours
Low-speed train?
the 2.5 hours highway drive.
Oh, okay.
From the local road to the highway drive. That's the 2.5. So today, when we go over there, the first location is about the 1 hour high-speed train. The high-speed train runs around about 200 miles per hour.
I love the high-speed train.
So
it's so smooth.
It's very smooth, very convenient. We get over there. So 7 separate locations. Then you wonder, why do you do 7 separate locations? Why you cannot just put everybody back together, okay, into the 1 location?
There's too much stuff.
No, not really. Let me tell you why, okay? Because by management point of view, it is more efficient if you put them all together under 1 roof, okay? The problem is you have to understand the Chinese local government,
the
local
regulations.
regulations. Each local government has a different style, or people are different. Some of them very easy to deal with it. Some of them sometimes very difficult to deal with it. So that being said, we literally have 7 locations under 7 different local government. So just in case one guy give us hard time, we can instantly shift everything to another location. Otherwise, you just have to deal with them. Obviously, we're smart enough. We can use 1 locations to negotiate for the other locations. For instance, you see Paul has a location, Leslie has a location, right? So Paul will go to Leslie and say, hey, you better behave yourself. Otherwise, I will take all the business away from you, or vice versa. That's how the game will play, to keep sure we are in a safe ground in China. Because let's face it, okay, even I'm Chinese, we are in a Chinese local territory over there.
Yeah.
Sometimes in order to be safe, in order to be a kind of make sure our products are being made on time and this and that. For the same token, you will not believe this old days, for us to get electricity.
Oh, those are the old days though.
Oh yeah, but still today,
Happens?
and yes, still happens, especially summertime.
Oh, because they have
Right.
brownouts.
Okay, right. So those things, that's why we have 7 locations.
And
Okay.
Alice, one thing I want to point out about those 7 locations is it's not just one building like we have here in Cleveland,
No,
Ohio.
no.
It's like a campus.
It's a campus.
Buildings
Each-
on buildings on buildings. There's an office in
Right.
each one of them that's
So-
very formal.
So
It's
I would
nice.
say each location, when you're talking about each location, so we have like average of 5 to 7 buildings.
Mhm.
Okay, each buildings, this is pretty gigantic. Each buildings, you're talking about 100,000 square feet, a minimum. Okay, have 2 different floors, high ceilings, low ceilings. So you're basically talking about you have 7 different campus over there. Okay, with those, we employ more than 2,000 people over there. Okay, they're all TCP employees. Okay, and over there, we have a team over there, about 7 people. Okay, the 7 people actually is run by the guy's named Chi, but my brother is the boss over there.
Yeah.
Okay, Solomon literally managed the whole
So
operation.
it's kind of like you and I. You manage the
Right.
whole thing, but
I
I make
manage
sure
her-
the work gets done.
Right, work against
So Naichi's like me. He makes sure the work gets done.
Work gets
Solomon
done.
oversees the whole thing.
Right, so exactly. Okay, so that being said, the 7 locations are like we are showing you the videos. The first location actually is the LED chip making. Now,
Okay,
that one,
that's really cool.
that was more than 3 years ago. Okay,
2017 is when
right,
we started that?
right, at 17 we start with
18.
that. It took like a whole year and a half to. It's a brand new
Well,
building, brand new equipment. Everything is a brand new over there.
And that
okay?
campus is huge.
It's huge. It's gigantic.
Paul and I went there once.
Right, Paul?
Right.
Yes.
Right? That campus is huge. That
Oh, that's
campus is like a gigantic. It's like about 30 acres over there,
Yeah.
and you have gigantic buildings because those are semiconductors buildings. Inside, no dust. Okay.
So it's really fun. So we go over there, okay? And it's the product management team, and it's our first time seeing the facility.
Sure.
So we get there, and then they look at us and they go, "Here, put this on." So you
Yeah.
know, you've got your regular clothes on. I think we all had on polos and jeans and sneakers, whatever. And they gave us the electrostatic paper dust suits. So you had
Right.
to put those on, and then you had to put the booties on, and then you had to put the hat on, and you had to tuck all your hair up into the hat, and then you had to put the mask on,
Right.
and then you go into the machine. So then you go into this machine, and you're like, "Uh-oh, am I gonna die in here?" Because it's like going into a refrigerator, and then the air comes on, and it's like a giant vacuum, and it gets all the dust and the electrostatic off of you, and you're like, "Ah!"
Then you
don't
have
really
to
do that.
turn.
You have to do this.
Turn. Right. You have to turn. Right. Okay. So it is that there's no dust in those rooms because unfortunately this chips we are doing today.
It's high-tech stuff.
It's very high tech stuff. During the process, as you see those videos, you literally cannot have any dust in it. If when dust end up on a surface
Ruin
on
it.
those chips, it ruins it. It
So
just
should we show them
ruin
the
it.
video so they know what we're talking about?
Yes, we're going to show you the
Okay.
video. We can show the
Let me-
first part, right?
Let me get it.
The
teed up.
first part is how it's being made. Now, let me just say, before you show that, you're
Mhm.
basically going through, let's say, picking, welding, and phosphor
And packaging.
and sorting, right?
Yeah.
So you basically go through 4 stages, but the 4th stage is the not including the video. So let me quickly walk you through 4 stages, then Leslie can give you the detail. First stage is this: we buy the wafer from the wafer company, let's say from Taiwan. It's a 2 inches, 4 inches disc. Those wafers are extremely thin, thinner than your hair. Then we cut those wafers in a smaller little piece. Actually, when you see a LED today, the real LED chips is so thin, your eye sometimes cannot recognize
It's
it.
thinner than a strand of hair.
Right. So it cannot be touched by human hands. Everything has to be done by machine. There's high speed, high accuracy machines. We do called picking. So pick it from trade of the LED wafer to place we call the substrate, which is substrate could be ceramic, could be high quality of the plastic, could be in a square version, could be in a strip version, like we're going to show you on a strip version. That's the first one. The second one is when those things has the leads on both sides and they need to be connected. That's what we call welding. The only way we can do the welding is very high speed welding. After that is then you move to the next stage, which you put a phosphor. Okay, the phosphor actually is where the magic start coming. The phosphor involves the two different areas, which we're always talking about, the CCT and CRI, right? Which is the color and the color rendering index. So when we talk about colors, you will see we have 9 different colors today, from 18, 22, 24, 27, 35, 35, 41, 5,000, 6,500. We have 9 different colors. Nobody able to do that. For us, it's not that difficult to tell the truth. That's when order come in from TCP internally, go to the factory, they say, I need 2 million strips of the 1800. Boom, they put 1800 phosphor because they mix the phosphor on a daily basis. All those phosphor must be used up that day. Okay, it cannot drag on to the next day. That's why color, why we always say we are the big guy in the colors. It's not like we're big because we have our own ability to manufacture, which is no other people able to do it. Because let's say a lighting company in the United States, they place the order to the supply in China. Supply in China, they need a special color. They have to go to the open market to buy it. We don't. One single computer order, internal order shoots to our location over there. Boom, magic happens. Okay, so that really gives you tremendous amount of flexibility. For the second part also is critical to us is the color random index. Now today we have a 3 color random index. Number 1 is every day we're using CI80. It's a standard. Okay, and also you have CI80, CI 90, and a 95, which we call high CI. However, TCP Solistic is different because people can offer you CI 90 to 95 still with a blue peak in it. But TCP also have not just 90, 95, we also have a 97 with a no blue peak.
That's our Solistic that we talked about yesterday.
Right, that's become a manufacturing process through the combination, the chips and the phosphor together to make that happen. So that's the second very critical point. Why TCP today able to offer you different variety of the products actually is directly related to the light source, which is the chips. Okay, obviously other people can do that too, but make their life very complicated, very difficult because they have to jump through 5 or 6 or 7 hoops in order to get the products they need. The third thing is extremely important is the size of the chips. Because chip today, about 30 to 40% of cost of any lighting products. If you have, let's say, big light bulbs like that, and you have a 40% of cost of these light bulbs on the chip side. Now, today, something make our life a little bit complicated. It's called DLC standard, DLC premium, and all non-DLC, like everyday inexpensive products. You will have a light bulb with a Energy Star and a non-Energy Star. Am I right, Leslie?
Correct.
Now, all of a sudden, we do that, people expect so-called non-Energy Star, so-called non-DLC has a higher price in it, or has a low cost in it. How do we do that? We play the games on the size of the chips. Okay? With that, we're able to cut a smaller size of chips. I'm always using this term called good enough. That actually is a challenge to us because sometimes when we want to shave off a couple pennies on that, we always go to our LED packaging guy first, say, hey, do you have a smaller chips? They say, okay, tell us how small you want to be, what's the aluminum package you want to be, I give you something called just good enough chips. That makes us extremely flexible. That's why we're taking care today. If you look at 3 major benefit we have when you manufacture LED chips, you accomplish 2 things. Number 1, we have such good cost structure. We're able to share that with you, make sure, put you in a very competitive position in the market today. That's number 1. Number 2 is almost to a point. Why Paul able to kind of play his game, give you special products? One of the reasons he's able to do that, because he able to work with the China team using different size as chips, deliver you different type of lumen per watt and a total lumen package. Just like the other day, people look at our GPS strips, they say, we want 8,000 lumens. You know, Paul, whoever asks you a GPS 8,000 lumens?
That's kind of like a highway almost. I mean, but you know, people want what they want, so we're happy to do it.
It's very simple, okay? Paul reach out to the China team, say, hey guys, I need y'all to use the good chips. Boom. They said, increase the 2 size of the LED chips, bump up more lumens, almost like that. That's why manufacturing force is so important. That's why manufacturing able to give you the service you deserve, give you the products you need for your projects. You see what I mean? That's why TCP able to offer you the flexibility nobody able to do it because of manufacturing side. So that's kind of chip, right? The other 7 locations, that's one of the 7. Okay, that's the one we're very, very proud of it. But the other 6 is how you put things together right now. Okay, you have chips on one side. I always say that you have a driver on the other side. Okay, and you have all kinds different type of material shapes of the we call housing in the middle. Okay, that's what the POS team magic started. Okay. That's why we're talking about how we manipulate the lights now through 3 different elements. Okay, this is huge for us. And obviously factory at the end of the day, they are so good what they're doing over there. We are really efficient over there because each product, they calculate how many steps, how many components able to put together a finished product, how much time we're going to use. That's how we control the cost over there. At the meantime, 2 sides very transparent. US side able to see the production capability or the production. They can even see every day what they're making over there. That's really the manufacturing coming as such big play. That being said, how about the manufacturing we're supporting you guys for the service? Actually, like you guys see, what you see in our warehouse is the beginning of the chip. So that's a 2 extreme. Mm-hmm. Okay.
Well, you see the end.
I said the end or the beginning?
They saw the end. They haven't seen the beginning yet because we haven't shown them the video.
Oh, we haven't shown the beginning yet.
Right. You've just been going on and on, talking about all these great things that they didn't get to see.
Leslie, why
Can we show them the video?
Why don't you take us to the beginning?
I'd love to take people through the beginning.
Right, that's the beginning. We love the beginning. Stay there for a second. Okay.
There you see that outfit I was talking about.
Right, just look at the picture. That's what the Leslie looked like when she went there. I'm not kidding here. Okay.
I was more stylish. They put me in yellow because I think
they put you yellow. Yeah. I think all the yellows for the visitors.
Yeah, yellows right. For visitors.
Actually,
they wear different color, like I'm gonna call them scrubs because I don't know what
the
right
why?
Word would be.
Would you tell people why?
So they wear different colors based on the job that they do.
Correct.
And the managers all wear one color, and then the workers wear a different color.
Right. And technicians another color. And a foreman's another color. Right.
So when we were there, we wore yellow because we were visitors.
So unfortunately, we're outsiders.
Yeah,
right?
That's cool.
Okay.
I just didn't want to get lost because the building's like a maze.
Right.
But here we go.
Right. Look at
the amount of machines before I hit the go button.
Okay. Normally, each person they're able to manage 20 machines because machines are so automated. Okay. Look at. Do you see all the red, yellow lights? That's red and yellow lights on each single machine. So actually, you see the computer panels, which they have the micro camera to shoot all the way down. They know every time when the things move inside the machine, they actually take a quick picture of that, so show you if the chip's able to position correct or not.
Yep.
In the normal circumstances, nothing is going to happen. Why are they able to manage 20 machines until the light turn into red?
Yep.
Boom, then they have to take care of the machine, could be out of material, out of the plate, out of this, out of that, could be anything.
Funky.
However, when they go to their machine to look at a machine, the computer will instantly tell them why the right light comes up.
Yep.
Okay.
Are we ready?
Yes. Here we go.
I'm gonna narrate. You just have to be quiet.
Okay.
Can you do it?
Yes.
Okay. So this is our LED chip packaging facility, and there you'll see the wafer, which Alice mentioned, we get from our LED suppliers, and then the machine's picking off those individual epis. That's the thing that's less than a hair. It's then mounting it onto that ceramic substrate. In this case, we're making filaments, we're using ceramic, and then that's the wire bond that it's going through there. After that, it moves over to the phosphor coating machine. The phosphor, as he said, gives it the CCT and the CRI, and because we're making filament strips, the machine flips it over to give it that 360-degree omnidirectional output on that LED filament. Now from there, they do a manual light up and they punch them apart. But one thing that I want to note is missing in this is they actually check them on the machine as well.
Correct.
So the machine, you don't see that. When they're doing that light up, it's not just the guy going through and making sure they light up. He's actually checking to make sure that it hits all of the specifications that we dialed it in for.
Because a strip's a little bit different from SMD. Okay?
SMD, it's automated.
SMD is complete automated. When you finish this, I want you to show people the SMD version. Then we will talk about how the SMD is being taken care of.
Yep.
Okay. So this is on the filament side.
Yep. So and then this is how they package them up. And then before they get transferred over, they're actually vacuum sealed so that they're free of dust, dirt, moisture, anything before they move over to the bulb manufacturing. So this is a different facility where you see the machine take the glass post and mount the filament strips on it. They wire it up, they do a light up test. And then after that, the glass post with the filaments is inserted into the glass housing where they insert a little bit of gas to help manage the heat. From there, a worker inserts the driver into the base, and then they make the final electrical connection with the pin. After this process is complete, a worker puts them all into the burn-in rack, and then they're sent over to packaging, and then they're shipped to the US.
Right. So you can see this is a complete process from beginning to the end, how the light bulb is being made. Now, obviously, what you show you, Leslie show you is a strips. Show them the SMD. If you can focus on, that would be great. Okay. Are you able to focus on it?
It's trying. There
Yes,
we go.
there we go. Right.
So those are the SMDs, and these we make how many billion a month, Alice?
1 billion SMD chips every single month. 1 billion. Okay. Sounds like a big number, but actually it's not. We are able
Look at
to
all the chips that are on this one little magnetic retrofit.
TA tubes using average the 100. A high base we're using up to 1,000 the big wattage. So it's not that.
That's crazy.
Right. However, even using lots of chips, I think we still able to. We only able to consume between 500 to 600 million of the chips of ourselves.
Okay.
We're still able to sell up to 50, sometimes 40, 35 to 40% of chips into the open market.
And when you say it goes into the open market, what does that mean, Alice? Anybody can buy them.
Anybody can buy them. I think some of our competitors using our chips too. We don't know. We don't talk about that because it's in the market.
Or they could use them for other purposes, like things where you don't necessarily need as good of color.
We sell them a little bit different. So what happens on the SMD version, I'm ask the check because I don't go there right now.
Right.
So they have to do that for us. They're going to shoot a video for us to you. Is every single SMD is being tested and checked in such high speed.
The bidding process is so cool. And I know
7 bins.
I took a video of it at one point and I couldn't find it. I went and looked back. But it's so fast. And what it does is it like the machines check it and they sort it all. So they're going through and then the LED chips are dropping into the correct bag based on where they fall within the quality. So it's almost like when you buy a new pair of pants, right? And if you get the first pair of pants that's cut off the pattern, you know it because they're going to be big. But if you get the last pair of pants that are cut off the pattern, you're not going to be able to fit in them because they're going to be too small. And then you're going to think you gained a lot of weight. The bidding process is kind of like that, where it's checking the quality based on the machine and kind of where it fell within that wafer, and then how it came together during that process and how it turned out.
Actually, the problem comes from the wafer, like you said. Here's what happened. If you have a wafer, let's say that big, let's assume this is 4 inches.
So that's our LED for little wafer. They're about this big.
When we buy, okay? When we buy this, actually the whole thing like this, obviously we cut like this, okay? Okay, we cut like this. Now, remember, wafer, I wish I take another picture for you someday. The wafer is a growing of a silicon. So in other words, you have a drop of silicon start from the middle. We're using high voltage electricity, okay, with a chemical process start growing, growing into the wafer like that. Now, today the technology is this, okay? Only the middle portion of the 10% is the best, the best, consistent.
So they go in like bag 1, right?
Okay, then it go on like this. The outside here, the 10% of here,
Those are the worst.
those are the worst for the Christmas lights. Now, let me put it this way, okay? If today, because we're not in this business, if the wafer grower able to grow the wafer from 10% of the best to 50% of the best, who able to come out this technology, who will make so much money on it? And all of the sudden, this cost of the LED chips will drop by half the price. But nobody can able to figure out that. Because of this variation in the wafer, force us at the end to test every single one. Not just you testing on the consistency, you're testing on the lumens. The little lumens, they have a light sphere like that big. Versus like because we connect them by voltage. They test every single one in a high, fast speed. Okay, so that's how we do it. And then obviously we want to make sure we have the best of the best for ourselves. And unfortunately, the seventh thing, you don't sell by pieces. You sell by
the
pounds.
Yeah.
By the bags. Okay, so there's another business in China today, just for talking purpose. People using the bags.
Okay.
You have a bags for the filament, you have bags for the SMD chips, you can bags for all the electrical components because they do exactly the same way. Those people put a light bulb together, they assume 15 to 20% or minimum 10 to 15% will go back guaranteed. But the price is so low, they figure out
if I mix it, it'll work out.
If I mix it, it'll work out. You see, that's the dark side. How about that? Okay? So
But
that's how
we
we don't do that. We pick the first one instead of the last one. I just tell you other people. Now you
We
understand
only work
why
with the
they able
first
to do
3
that.
bags. The rest of them we kind of sell out.
Right, but now you understand how those inferior products come in.
Absolutely.
How do they do it? They come in from the other side. Okay, so that's what the steps, everything we go through here. Okay, this is really cool. I think, Leslie, we should produce a video just like following on that, but in such a steps that the China, our team over there will give you each steps of
We
video.
have some other piece parts
right,
too.
that
We just
would be
need to
really cool.
figure out where they are and who had them, and 2, if we can make them work. Because we had some really neat videos about that. In fact, we had some that were slow-mo of taking the little wafer and picking the individual EPIs off, and with the,
So that's really cool, right? That's how we call the manufacturing process. We spent a lot of time to that. You know, what I really get excited about this whole thing is not just China team, the US team. Look, Leslie loves to go to the factory, dressed up. She's so hands-on, love to sit on the line, hang out with those workers over there, making things.
I like to tell them what they're doing wrong.
The entire US team love to do that because we have ability and we have the way to do it because our own factory. Otherwise, usually people don't want to let you know how they make things.
Or they let you in, and
right,
it's you only get to see like the one piece of it, right? Like you only get to see the glitter and sparkles, dressed up, you know, put out your Sunday best piece of it when you visit factories that aren't your own. When you go there, you're with your teammate that just works on the other side of the world, and they're explaining that process to you. Just like when they would come here, it's the same thing. Like if we wanted to help improve a process on our line out there with our US assembly, they'd stand there and we'd work together, and then they'd see like, oh, now it makes sense why the US team's having a hard time assembling this. It's because the tools that they have, or you know, their fingers are bigger, or whatever the case may be.
I'm not kidding here. Even the finger matters. The finger matters because involved with the size. I mean, we have a perfect example, right?
Sure.
We have a perfect Okay, example.
We have a lot of
Paul,
examples.
remember we have this junction box for the panels with only half a size.
Oh, yeah, that's a perfect
Remember that
example,
one?
Ellis.
Why?
So our
Because
old
the-
junction, we can talk about it.
Right,
Yeah.
right, and the
This guy.
people
Yeah.
over there, they
Junction
said,
box used to only be this
About
big,
That big, yeah.
that big, right? About that big,
Right.
right? Maybe
Yeah.
even a little smaller.
Right.
And we're like, ooh, it's fantastic. It's so small.
right,
Yeah.
And then it got out into the field,
Into the
like
field.
not us assembling, but out in the contractors. And you got to think about it, like, you know, you and I, we got pretty small fingers.
right, but
But you're
people have
looking
a
at
big
this
fingers out there.
guy, big
You see what I
burly
mean?
guy, 6 foot tall, long fingers, been doing work all his life.
Jared? Yeah.
George just got long.
You see,
fingers.
we are so good at what we do
So
right
you
now.
couldn't figure it out.
The so-called the reaction, you know, let me say this, we're not perfect. We are not,
No.
we are good as, let me put it this way. The team here in China, all of us here, we are extremely good to reach the result we wanted. Along the process, are we really good for every single idea we pump out or every single result we want to achieve? No. However, we are so good at it to improve ourselves, modify ourselves to achieve the goal we wanted.
Well, and because
So
we-
that's why I'm very good at it.
because we're working with our teammates,
Right.
we can make changes quickly.
So it's like once, twice, 3 times, boom, it's there.
So,
But normally the first time it may not be there, right?
Alice, we've had a couple of questions come in while we've been
Sure,
jabbing on. And one of them was asking about in the video that burn-in rack that we do at the very, very end.
right.
And no, it's not necessary that we burn the LED bulbs in. However, Ellis and Solomon are incredibly superstitious, and they very much believe that the bulbs should burn in for, I
Very
think you burn
simple.
them in for about an hour, don't you?
2 hours.
You do 2 hours.
Every bulbs have to burn 2 hours.
Just in case.
Okay, now I have a quiz for you guys.
Uh-oh, we've
Okay,
got a quiz.
Paul.
We had another question. Can
Paul,
we
okay,
the other
answer that
question?
question. Paul, come here to join
So,
us.
Paul, this one's actually for you. Do you have any fixtures that are fully made in the USA
Oh, yes,
that
I
would
do.
qualify for an American-made product?
Yes, I do. Let me show you one. Ooh, let's see here. Here's one. Here's one right here.
So that's minus the tubes.
Minus the tubes.
Is made in the US.
This is a completely made in the USA product.
Okay, you also have a polo bear.
Yes? Oh, right there.
Oh, Joe, look at that one.
So this is made in the US.
Also made in the USA. One more, Jared.
One more,
Your rappity
Oh.
rap.
Rapid Rat, and also the US paper type.
Also
Yeah,
made in the
remember
USA.
Also made in USA.
We also have a small version of this made in the US.
That's the big
Also made in
version.
the USA.
Made in USA.
We do a lot of assembly on the LED integrated side. We're working on ways on how we could do US on that. The problem with that is a lot of the components come from overseas. So we're working through how we could make that work.
So can I rewind a little bit?
Rewind it.
When somebody says made in the USA, by that statement, you're saying that you want product that is 95% manufactured materials from the United States.
Correct.
Correct.
Material from
That
the
is a
United States.
made in the USA
From
statement.
the US.
Now, if you say assembled in the USA,
We got a whole lot.
we got a ton more. I mean, we can go
That
across
means
the board.
components
about
coming from China.
components
Or
coming
anywhere.
Or anywhere.
Anywhere.
Yeah.
We follow the rules called assemble. That means we have to go through certain steps, the details. Enough.
Significant transformations.
So what's the word?
Significant transformation.
Okay, right.
To meet that ARRA.
So my ARRA requirement.
So we hope that answers your
Right.
question.
So we do have a tons of the ARRA program. The made in USA is a tough one. because
Very
it's
tough.
95.
Very tough to do.
Just
We're
'cause
probably
you
one of the
can't
few
find
that
the
do it.
Right. Okay, now,
Now's the quiz.
okay, now is the quiz.
What's
They even
quiz?
don't know what
I
my
never
quiz
know what's
comes
gonna
from.
happen
Uh-oh.
on these.
So Paul, you
Yeah.
saw that, no, Jerry and Nick, you guys can jump in.
Oh,
See
even
if
better.
you can do it. You guys see, I mean, we're very superstitious, Solomon and I, we burn the light bulb for 2 hours, right?
Even though you don't have to.
So let's say you have a brand new fixture Jerry put together,
Okay.
okay? And we do the qualification, this and that, blah, 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 all right? All the design, everything's cool, is done.
Yep.
We have the UI, everything's done, right?
Uh-huh.
So we start making, right? So let's say 8 o'clock start making, and 9 o'clock and 10 o'clock, we have 100 pieces, 200 pieces off the line right now,
Yep.
right? Solomon is still very superstitious,
They still
Okay.
burn them.
right? Okay, so how do we burn it? How do we burn the fixture? At what condition burn the fixture for me to have a peace of mind to ship their products? Guys, at what condition those fixtures, I'm not talking about eyeballs, at what condition those fixtures assemble from the line, burn it before I say go. And obviously,
Doesn't he just do normal operating environment?
No, I think he's probably doing it at the extreme temperatures, both on the driver and the LED configurations to make sure that that heat sink and everything's functioning properly. So very, very high temperatures.
you see, I
Make
told
sure
you,
everything's good.
I told you Paul knows everything. Paul, may I ask you at what temperature are burning?
Today?
No. As
Oh.
my scenario, I want to make sure.
Oh,
Because from making off the line packaging, usually when you start making to get on a boat,
Yep.
start shipping, it's like 5 days.
Yeah.
Okay, it's not overnight. So
Yeah.
before they load it into the container, and what condition those products being made 5 days ago, which I was signed off to get on the container? At what temperature?
That I'm not positive on.
Give a
but
guess.
I'm gonna guess it's probably around 75 C, somewhere around there, maybe 80.
We call 85, 75.
Hmm.
What does 85, 75 means?
75.
You burn it at
Thank you.
75 degrees for 85 minutes?
No,
No, I think he's doing a 75 minutes at 85 C.
no.
Oh.
Damn it.
Darren, it's called 85, 75. That's what that means. Okay? Can anybody help them out? 75, 85. No, 85, 75. Okay? Looks like I have to help them out.
Help us out, I'm confused.
80.
I am remembering the bunch of
that's what I was
fixtures
trying to do,
going
thinking
around
about
the thing, and they went through, it was like a
Okay.
little oven.
What
Now
will
it's not
damage?
long.
What? Okay, 85 is the temperature.
Okay,
Yes.
Okay?
I'm learning something.
Right, 85 temperature, because
Right.
you literally, the one way to test this product is going to survive or not, all your design, all your synchronization works
Mhm.
properly, there's one way to do it, destroy it. How do you destroy it? High temperature, 85. They
Okay.
either will destroy the driver or will destroy the chip, one way or the other.
Right.
If the after 85, let's say not too long, normally we like to do 250, but for the shipments, we cannot do that. Usually 5 days, 3 to 5 days long enough. Okay, if able to survive in 85 chambers for more than 100 hours,
Yep.
you're okay, you're safe.
So you look for 75.
What's the second one able to destroy that fixture? Jerry?
The second what?
Second condition will destroy
Two
the
conditions,
fixture.
Jerry.
Two conditions.
Two conditions.
The water.
No.
Relate to
no,
water,
no.
correct, relate to water,
Isn't it the moisture?
Yeah. the
Correct.
moisture.
Humidity?
75 humidity. And that's
We
called
got there.
85 and
So you
75.
put in the chamber.
While
I thought
you
it was
were
going
quizzing
electric.
us,
We're going to the chamber now.
We're-
You sample, you go to the chamber,
the chamber looks like a pizza oven to me.
like a pizza.
We should show them that at some point.
Yeah, I
don't
have the
thi-
picture
I don't know
next.
if I have
So
we
you know
have
what I
some
mean,
here.
guys?
Right.
That's I tell you, it's you see, we call it gatekeepers. Okay, what's a gatekeeper? Before you load it into that container,
We try
Okay.
to break it.
we try to break it.
Gotta
Well,
know
it's a
what
quality
you know.
check.
It's a stupid quality check, but this is the way how you
Once
do
it
it.
gets in the
I
field,
tell
you
you-
know what people are gonna
I
do.
tell you, even that,
Even if it's not rated for it.
no, guys, even that, we still have a problem sometimes.
Every once in a while.
Every once in a while. That's what I'm saying. What kind of nerve-wracking those things, because all the effort we put in, you will still have a problem.
So-
However, hold on a second.
Okay.
However, if the problem does occur in the market,
We take care of
Okay.
it instantly.
based on the date codes, they said that we all of a sudden trace all the way back. We find out
Completely.
completely for the who, how, what
What?
components, which day, AM, PM, and they go through entire process. You know what?
You know, the one thing that we didn't show was on the
The
US
quality,
side, we
yeah.
do both.
Mhm.
So like not only on the China side do we do that, but we do it on the US assembly as well. So let's say all of our China components are A-OK, ready to go. When we do the assembly here in the US, we have that on our stickers as well, so we know who made it. So that way we know, like if, you know, Joey out on the assembly line is making a fixture wrong every single time, he needs to get some more education.
But also let me say this before I let you go is
Well, we had one more question before you let us go.
okay, right.
The people want to know things.
Okay. Every time things happen, the bad things happen to us. After we trace all the way back, okay, after we did a complete study,
Yeah.
every single time,
Fix the issue.
okay, the China team will tell me in a very nice way, say, Ellis, we missed it. That means they missed certain little things
Yep.
which caused the problem.
Absolutely.
Okay, so far, I haven't run into any situation, things happen in the market, we didn't know what happened. We actually literally know exactly what happened, just we missed it. Okay,
So one of the questions was, what high bay do we have that's and what is the highest and lowest temperature rating that we have.
There we
And
go.
Paul,
There we
this
go.
is all you.
This is our
It's actually all Jared.
It's
But,
all Jared, but I'll talk about it, and he can correct me when I get it wrong.
okay.
So this is our HBM unit. It's our high bay, and it's modular, so you can put up the 3 together, and I'll show you that in a minute. But this is rated to 75 degrees Celsius. That's 167 degrees Fahrenheit.
167 degrees.
Yep. So we always joke around about this. If we go in the sauna at 167, we're not going to make it. Me and Ellis will be gone, but this thing will be going
But
strong.
Paul, I have to point out, when you say 75 Celsius and 167 Fahrenheit, that's ambient temperature,
Ambient.
not burning
That's
temperature.
not a spike.
It's not,
That's
you
a
will
everyday.
live,
Lives
right,
in that.
live in that,
In the fire.
In the
in
fire.
a fire.
Mhm. This was designed for steel mills originally.
Now you talk about moisture, right? Now,
Yes.
moisture
Now,
water
When we
related.
talk about moisture now, this is IP67 rated, which means that when Jared, because he likes this so much, he wants
Puts
to
it in
take
the
this everywhere
bathtub.
with him. So when he goes in the shower and in the bathtub, he can take this in the bathtub with him, and this unit will sink down to the bottom for up to 30 minutes. It's going to be okay submerged.
And how
IP67.
cold can you get?
So this will go down to about, I think it'll go to
-40.
minus 40, but I'll look and see on
It
that.
is negative 40.
It's a negative for
Mhm.
And you called it modular because,
You put up the 3 this way or end to end.
and then do you know the vibration rating for that fixture?
I do not. I don't think we tested the vibration rating on this.
Oh, we can.
No,
We-
we could.
we
It's a
didn't
different
test on
UL.
that.
Send it back to
Yeah.
UL for testing. But yeah.
I
Yeah, we don't
can
know.
test that.
Uh-oh, here we go.
You want
Don't
me to
do
do this,
that.
guys? Don't. Yes or no? Vote it.
Throw it?
What
Yeah.
are you doing?
Are you
with
gonna hit
that?
Jared with it?
No,
Yes.
stop.
They say don't do it, so otherwise I would do it.
We
What's
have
that?
This is a
gone-
very
What's
tough
that?
unit.
So we are over time. We have lost control. Thank you for joining us today. Remember, tomorrow we're taking tomorrow off, so we will not be seeing you tomorrow. But we really do appreciate you walking through, stepping through.
But in the meantime, we're doing lots of videos right now,
So
our
many
China
things.
team, so you can ask us, hey, I want to see a specific segment, how you guys put together.
Yeah.
We will send a video to everybody to share that with you guys, okay?
Absolutely.
Right.
So we'll see you all next week. We
Yeah.
appreciate you, and we'll talk later next week. Thanks, everyone.
Thank you. Have a wonderful weekend.